All right, moving on. So let's look at another set of examples. Okay, so given that cosine x is -5/8 and that x is between pi over 2 and pi, let's find sine x over 2. Okay, so once again, if you want to give this a shot on your own, pause the video, right? Try it out. I'm going to go ahead and work this thing out. And I'm going to use a half angle identity. I think right off the bat, right, it's like sine x over 2 is plus or minus square root 1. Now I always forget if it's plus or minus, but I think it's minus. I think the half angle identity for sine is minus. So this is 1 minus cosine x divided by 2. Let me double check. Is that right? Yep, 1 minus cosine. Okay, so there's our identity, and we already know that cosine x is -5/8, so we're set up, right? We're ready to finish tackling this thing. The only kind of tricky thing is we have to figure out what sine this should be, and for that, I mean, if we look at the fact that x is supposed to be between pi over 2 and pi, so x is in quadrant 2. If x is in quadrant 2, then x divided by 2 should put us back in quadrant 1, right? I mean, if x is, the biggest x could be is, you know, just under pi, just under 180 degrees essentially. And so let's say it was like 179 degrees. Well, when you divide 179 by 2, you're gonna end up with 89.5, right? Which is in quadrant 1. So if x is in quadrant 2 there, then x over 2 should definitely be in quadrant 1. Sine's gonna be positive, right? Sine's gonna be positive in quadrant 1. So I'll say sine x over 2 is, we're taking the positive square root, okay, so it's going to be square root 1 minus cosine x is -5/8, and then divide by 2. Okay, so the rest is just simplifying now, right? So we can say, okay, this is going to be square root of 1 plus 5/8 over 2. We can multiply numerator and denominator by 8 to clear that complex fraction. So I've got square root of 8 plus 5 over 16. 8 plus 5 is 13. Oh, and the square root of 16 is 4, right? So I can just call this root 13 over 4. And that's it. Okay, so there's that one. Let's look at another one. Same flavor of question, slightly different. Nope, this is example 3. Okay, given that cosine 2 theta is 1/2 and that theta is in quadrant 2, find cosine theta. Okay, so give the video a pause see if you can work this one out on your own. Honestly, this is one that I would probably not opt to use a half angle identity on it. I feel more inclined to just use a double angle identity on it. You know, because I could say cosine 2 theta is, 2 cosine squared theta minus 1, and then solve for cosine theta from there. So that's using a double angle identity, but I think, let's try to use a half angle identity, see where it leads us. I mean, we're trying to find cosine theta given some value of cosine 2 theta, so you can see how a half angle identity might work out for us. In other words, I'm kind of thinking like this. If we make the replacement that 2 theta is equal to x, then theta would be x over 2. And so essentially we're looking for cosine of x over 2, right? We're looking for cosine of x over 2. Let's do it. Okay, so I'm going to say cosine x over 2 is plus or minus square root 1 plus cosine x, all divided by 2. Cosine x, we were told, is equal to 1/2. Oh, and we should decide what sign to use, right? Theta is in quadrant 2. That's x over 2, right? X over 2 is in quadrant 2. Is that right? That can't be right. Oh no, that's fine. Okay, that's fine. Yeah, that's fine. Cosine 2 theta must be in quadrant 4 then, right? So theta is in quadrant 2, but it's a big enough angle in quadrant 2 that when you double it, you end up in quadrant 4, right? 2 theta must be in quadrant 4 because we're getting a positive value for cosine there. Anyway, but yeah, theta is in quadrant 2. That means x over 2 is in quadrant 2. So we should be getting a negative answer here, right? So we're getting a negative answer here. This is going to be negative square root 1 plus cosine x is 1/2 over 2. And that's that. The rest is simplifying, right? You can multiply by 2 over 2. And you get negative square root 2 plus 1 over 4. So that's negative square root 3 over 4, or in other words, negative root 3 over 2. Oh, which is a familiar answer. That leads me to believe we should have been able to do this, I think, without even using a half angle or a double angle identity. I mean, let's think about this, right? If cosine 2 theta is 1/2, then that means theta is either, well, if we're in quadrant 1, which we know that we're not, but if we were in quadrant 1, cosine 2 theta would be 1/2 if 2 theta was equal to 60 degrees, right? So the corresponding angle in quadrant 4 would be 300 degrees. So 2 theta must be equal to 300 degrees. That means theta must be equal to 150 degrees, right? Which definitely puts us back in quadrant 2. All right, if theta is 150 degrees, cosine of 150 degrees would be negative root 3 over 2, right? Okay. Anyway, so a whole bunch of different ways that you could get that, but here's how you would use a half angle identity to do it. I don't think this is the best way of what we've written out. But hey, you know, it works. So so you've got lots of options. Trig is kind of like this. It's like you have so many different options. You just try out, you know, try something out. Anyway, I'm going to give you another. I want to prove a few identities as well. So we'll do a few identities in the next video.